Welcome to Ms. Parb's Flipped Classroom. In the last lesson we looked at how to solve a system with graphing. Now we're going to look at how to solve a system algebraically. And the objective is to solve systems using either substitution or elimination. And our first example is substitution. The way you might decide that you would want to use substitution is you look at your problem and notice the coefficients of x are 3 and 2 and of y are 4 and 1. If you have a variable whose coefficient is 1, then substitution might be the easiest way to solve the problem. So because this has a variable of 1, we're going to take this equation, we're going to subtract 2x from both sides and solve it for y. And so now we know that y equals a negative 2x plus 10. So any place we see a y, we can replace it with this expression. So we go back to our original problem, 3x plus 4y equals 12, and in place of y, we put our negative 2x plus 10. Distribute the 4, combine our like terms, and then subtract 40 from both sides, and divide by 5, a negative 5, and we get x equals 5.6. Now that we know what x is, we can go back to either one of these equations. It doesn't matter which one. I picked this one because I thought it looked easier to solve. And in place of x, we're going to put 5.6. So we have 2 times 5.6 plus y equals 10. Multiply that out, subtract 11.2 from both sides, and we get y equals a negative 1.2. So our answer to this system is 5.6, negative 1.2. This would be our x, this would be our y, where the lines intersect. Okay, your got it is the problem x plus 3y equals 5 and negative 2x minus 4y equals a negative 5. Since you have an x here with a coefficient of 1, you can solve this equation for x, and then in place of x you can put what you got for your answer. And when you're finished with this problem, you should get the answer negative 2.5 as your solution for this system. Here's an example using elimination. Notice that none of our variables have a coefficient of 1. So it would be a little bit more difficult, and we may wind up with fractions if we try to use substitution. If we just look at this problem for a minute, we notice that this is 4 and this is negative 4. We know that if we add those, we get 0. So we can just add these. This gives us 0. This gives us 5y equals 25. Divide both sides by 5 and get y equals 5. Now that we know what y is, we can go back and substitute that information into either one of these equations and solve for x. So I picked this equation, replaced y with 5, work this out, subtract 15 from both sides, divide by negative 4, and I get x equals a negative 1/4. So my solution is the point negative 1/4, 5. And to check it, I go back to my original equations. In place of x, I put a negative 1/4. In place of y, I put 5. And I check to make sure that I got the same answer that it said I should have gotten. And then I check the second equation, because remember, you have to check both equations. So I replace x with negative 1/4, y with 5, and work this out, and I get the same answer. So I know that this is the correct solution for this system. In this example, none of the variables have 1 as a coefficient, so we don't want to use substitution, but none of them are opposites either. So if we just added what we have here, we would still have an equation with 2 variables that we don't know. So I took my 2 equations, and I took the 3, which is a coefficient of this x, and I moved it up here. And I took this 2, and I moved it down here. And then I made either the 3 or the 2 the opposite. It doesn't matter which one. I just chose the 3 because it was on top. So I made this a negative 3. My goal is to get rid of one of these variables so that I only have one variable and I can solve the equation, and then I can go back and find the other variable. So I multiply this whole equation by negative 3, and I get a negative 6x minus 21y equals negative 12. I multiply this whole equation by 2, and I get 6x plus 10y equals a negative 10. They're still the same equations, they just look different because we multiplied them by a number, but since we multiplied the whole equation by the same number, it's still an equivalent equation. When I add these, negative 6 and positive 6 cancel, so that goes away. Negative 21 plus 10 gives me a negative 11y. Negative 12 plus a negative 10 gives me a negative 22. Divide both sides by a negative 11 and I get y equals 2. Now that I know this piece of the puzzle, I can go back to my original equations and I can use y equals 2 in either one of these to solve for x. And I just chose the bottom one. In place of y, I put 2, give me 3x plus 10 equals negative 5. Subtract 10 from both sides, divide by 3, and I get x equals negative 5. So my solution is the point negative 5, 2. On your guide, you have two systems to work. You're going to want to work them the same way we did here because none of your, well, I'm sorry, this one, these are the same but opposite, so you can just add those. This one, these are all different, none of them are 1, so you'll want to work this problem like we did this one up here. And when you work these out, for this one you will get the solution 4, 0. And for this one you will get the solution negative 2, 3. Okay, the systems we've been solving all had a single point as a solution. They were lines that crossed to form one solution. Sometimes you have systems without unique solutions. Remember our dependent system, which has infinite solutions, and our inconsistent system, which has no solution. When you work those out algebraically, they're going to look like these problems. Notice when I add everything here, I get 0 equals 0, which is a true statement. If I get a true statement, the x is gone, the y is gone, and this is true, it means it's an infinite number of solutions. It's a dependent system. If I add these, the x is gone, the y is gone, all I have are numbers, and this is a false statement. It means that there is no solution, and this is an inconsistent system. So on this guide, you need to check these two systems to see if you have a unique solution, if you have a true statement, or if you have a false statement, to see what kind of a solution you have. And on this first one, you get no solution. So it is an inconsistent system. And on the second one, you get a true statement when you work it out, which means you have an infinite number of solutions, and this is a dependent system.